Hey guys, I hope you're all doing good. So this video is just a follow-up to the genetic algorithm video that we had looked at last time. So with respect to the assignment, you are supposed to find the minimum value of the stalagmite function. Now, if you had done some reading about GA, you know that it is actually based on random sampling. That is, you start with random number of inputs, and based on the inputs, you evaluate the function, and then comes the concept of natural selection, where you take two generations, you basically mutate them, and you also do crossover, and then you create a new generation which is hopefully better. One thing that you might have noticed is every time you run the GA code, you would get different results. Now this brings us to an interesting question, right? So how is GA then usable if it's giving me different results every time? So to demonstrate this, first I wrote a code where I'm actually looking at the statistical behavior of the genetic algorithm code. So let me go over the code that I've written. So first we get started with clear all, close all, and CLC. I hope you all know what that does. And then I create my X and Y. Now remember, X and Y is the input arrays for X and Y. This does not define the search space for the genetic algorithm. We want this to be the search space, but genetic algorithm doesn't know that this is actually the search space. Meaning it doesn't know that the values for X and Y can go beyond 0.6 or it can go below 0. All right. Then what I do is I have this parameter called num cases, which is set to 50. So the idea is I'm going to be running the genetic algorithm 50 times. And we have this function called get stalagmite, which basically generates the stalagmite function. The first study is just calling the GA, and I'm just passing the number of variables as inputs. And what I'm then doing is I'm just storing the X values and Y values, and also the optimum value that the function predicts. After that, what I do is I open a new figure window and then create a subplot. So the idea behind a subplot is to have multiple plots inside the same figure window. The first plot that I create is the surface. I'm just looking at the stalagmite function. And then what I do is I use the plot3 command to plot X, Y, and the optimum function value that GA predicts over the 50 studies. All right. So why is this important? Well, this helps us visualize how the algorithm is performing. And to make this plot a little bit more clear, we create a second subplot. And in the second subplot, we directly plot the optimum value that the function is predicting as a function of the iteration, which is basically the case number. So this is the first study that we are going to run. All right. And then to measure how long it takes to complete the study, I'm just going to include my timers by using the tick and talk command. And I'm just going to select all of these guys and then use the evaluate selection option and wait till the run's complete. All right. So first, let us take a look at the first plot. And I'm just going to use the rotation tool to kind of show you what's happening. So here you can see that I'm plotting the stalagmite function, and then I'm plotting the minimum values that GA is trying to predict. And you can see that it's all over the place. And this happens because of random sampling. Each and every time I run the code, I get different results. If this plot is confusing for you, you can look at the plot in the bottom. X-axis is the iteration. So in this case, we are running GA for 50 times, right? So that is what I'm calling as iteration. And during each iteration, the value changes. The minimum value changes between 0 and -1. And this result is actually not usable. So if you have completed the challenge till this part, then this means that your results are completely wrong. Okay? And this is one of the things that I wanted to mention. The videos that we provide in this course, okay, are going to provide you a starting point. It's going to help you understand the problem, but it does not provide the solution to the challenges. For the challenges, you will always have to read a little bit more. You have to do a lot of numerical experiments. Only then you will be able to figure out the right answer. Don't treat this course as a traditional course. In this particular course, we are actually teaching you how to code. So if you research the problem before start coding, you will learn a lot. And remember, that is the most important thing. Finishing the challenges on time is not important. Finishing the challenges by first understanding what the problem is and then developing the skill set to work on open-ended problems is what we care about. All right. Okay. So now that we have identified what the problem is, let's come up with some solutions. So this is where study number 2 and study number 3 comes. So the first thing that I did is I set up the bounds for the variables. So you saw that x and y was actually going below 0 and above 0.6. Okay, we want it to be between 0 and 1, or you can also be more specific and you can contain it further. You can do this by setting up upper and lower bounds, and that is what I've done here. So to set up the upper and lower bounds, the function definition changes a little bit. I want all of you to search the syntax for GA and understand what these inputs mean. I'm not going to be explaining that. Please take the time to understand how those inputs work. So here I'm just giving the x and y upper and lower limits, and then after that the same thing, I'm running GA, and then I'm just registering how long it took. Okay, so let's actually run this guy, and this is going to take a little bit of time. Okay, so you can see that took about 31 seconds, and this time our plot looks a bit more cleaner. So let me rotate the first plot, and if you see this, you can see that the function predicts that the minimum point is between the 3 mountains that you see here, between the 3 peaks that you see here, which is much better than our previous code. And you can see that if I look at the y-axis, now the minimum value is between minus 0.75 and minus 0.95, which is a much more narrow range. All right, so this is still not accurate, but we are definitely moving forward in the right direction. And the only thing that I had to do is to reduce the search space. Now, when you run optimization, it is very important to understand what your search space is, and you need to make sure that you configure your genetic algorithm appropriately. As far as the search space is concerned, it depends on what type of problem you're solving. Now, if it is an internal combustion engine simulation and you're trying to optimize the piston design, and if you want to include the effect of spray angle into your simulation, then you need to know what is the lower bound and the upper bound. You need to make an educated guess, for which you need to have the application knowledge. All right, so this is our second attempt. So the next thing that we want to try, all right, so this is our second attempt. All right, so now let us move on to the third study. So in the third study, what I'm going to do is, in addition to specifying the bounds, I'm also going to change the initial population size. Now, as you know, genetic algorithm starts with random samples. So by default, GA takes 50 as the number of samples. So since there are 2 variables, you are going to have 50 sets of 2 random variables, and that is going to be your population. Now, if your initial population is too small, then it can actually not find the global minima, but it can actually find the local minima, which is what happened in study 2. So what we are doing is we're increasing the population size to 170. Now, the drawback of this approach is that this is actually going to slow down GA, because you have more number of samples, you have more individuals, and you need to process them and then evaluate the function. All right, so this is going to definitely increase our simulation time. So let us run this and see how long it takes. Okay, so the results for this study is up. Now, if I actually rotate the top plot, you can see that now the minimum value is just falling always between these 2 peaks. And if you actually see the bottom image, you can see that the minimum value is always around minus 0.96, okay, except for 2 iterations, right? So only in 2 instances the GA actually predicts that the second peak right here is the minimum value. Now, this problem is definitely going to go away with more number of iterations. So in this case, you can see that study 3 took 72 seconds. So that is 3 times longer than the first study. Okay, so obviously if we have more iterations, it's going to converge into the minimum value irrespective of the number of times we run GA. Okay, so this is an important aspect that you need to learn, and oftentimes to come to a conclusion like this, you need to understand first how GA works, which is what the goal of this exercise was. So make sure that if the video is still unclear, you understand how GA works. In fact, as part of your challenge, you're supposed to figure out that, and then attempt this problem one more time. Okay, all right, thanks, bye.